Hello and welcome to this lecture. In this lecture, we will cover a very basic example that how to train machine learning model and develop Android application for it. These lectures are actually part of my complete TensorFlow Lite for Android app development Udemy course. So if you are interested in machine learning use in Android using TensorFlow Lite, kindly check out the course. Link is given in the description. So let's begin. Welcome to this lecture. In this lecture, we are going to start building our cats and dogs classification model. So we are going to use transfer learning with TensorFlow Hub. So what is TensorFlow Hub? It's actually a library for reusable machine learning modules. A module is a self-contained piece of TensorFlow graph along with its weights and assets that can be reused across different tasks in a process known as transfer learning. So module is basically used in transfer learning and it contains pre-trained weights and assets. So now let's start by firstly specifying the version of TensorFlow. So we are going to use TensorFlow 2.0. So here I'm specifying it. So now let's run this block of code and it will use TensorFlow 2.0. Now the next step is importing our library. So I'm going to import numpy, matplotlib.pyplot, TensorFlow, TensorFlow Hub, TensorFlow datasets, and a library called TQDM, and it will be used during testing. Then I'm going to print the version of our TensorFlow, which is actually 2.2.0, then the version of TensorFlow Hub, and finally whether we are using a GPU or CPU. So now when you run this block, you will get a similar information. Here you will get the TensorFlow version, which is 2.2.0, and then TensorFlow Hub version is 0.8.0, and the device is GPU supported. Now the next step is selecting the model. So here you have two options. The model we are actually selecting is actually a pre-trained model that we will use for our problem. So the first option is MobileNet V2 model and the second option is Inspection V3 model. So what is MobileNet V2 and Inception V3 models? MobileNet V2 is a convolutional model which is 53 layers deep, and it is trained on millions of images and it can classify up to 1,000 different classes. Similarly, Inception V3 is a convolutional network model which is 48 layers deep. It is also trained on millions of images and it can also classify between 100 different objects. So here using the drop down, you can specify the model you want to use. So when I click on it, you can see that we have two options, MobileNet V2 and Inception V3. So I'm going to use MobileNet V2 here. So here you can see that our model selection contain MobileNet V2 for now, and that is 224, that is the image size, and that is the output size for our image extractor or feature extractor, and I'm going to explain it later. And there you can see that we are getting the properties of the model we selected. So here Pixel will store the image size, which is 224, and FV size will store this value. Similarly, handle base will store the information that we are using model, which is MobileNet V2. And there you can see that we created a variable module handle and it's just indicating that the type of model we use. So you can just ignore it, but if you are interested, you can see that we attached our handle base at the end of this string. So we are actually indicating that we are using MobileNet V2 model here. Now we created a variable called image size. So actually these pixels contain a value 224. So the image size is its height and width. So its length and width. So it contains 224 by 224. Now at the end of this block, we are printing the information. So when you run this block, you will get the information similar to this. So using this address, so we are using MobileNet V2 model with input image size, which is 224 by 224, and the output dimension is 1280. The next step is data pre-processing. So we are going to use TensorFlow dataset to load our cats and dogs dataset. The TensorFlow dataset.load method downloads and caches the data and return a tf.data.dataset object. And these objects provide powerful, efficient method for manipulating data and piping into your model. Since cats versus dogs does not define standard splits, so we use subsplits feature to divide it into train, validation, and test, with 80% for training, 10% for validation, and 10% for testing. So here the first line contains a variable called split. So we are specifying that how much data we want to keep for training, which is 80%, and how much you want to keep for validation, which is 10%, and the remaining 10% will be used for testing. And there you can use TensorFlow dataset.load method to load cats versus dog dataset, and here you will specify the splits. So here you can see that we specified 80% for training, 10% 10% for validation and the remaining 10 for testing. And there you can perform the splits. So using this splits variable, you can actually assign the 80% training to the train example variable, and validation example will contain the 10% data set for validation, and the test example will contain the remaining 10% data for testing. Here you can see that num example will contain the number of images which is specified or retained for training, and that is 23,262, and num classes will contain the number of classes. So actually there are two classes, one is for cat and another one is for dog. So here these variable will contain that information. The next step is to format the data. So we actually wrote a helper method to scale our image and resize it. So here format image method will take an image and a label, then it will gonna resize the image to image size which is 224 by 224, and it will gonna rescale it by dividing it with 255, and it will gonna return the image and label. And the next step is choosing the batch size. So here batch size will specify that how many images we want to pass our model at a time. So if we specified 32 here, then 32 images will be passed to the model at once during training and also during testing and validation. So here I specified a batch size equal to 32, and there you can see that we divide our training, validation and testing data set into batches. So here train batches will contain the batches for training, so each batch will contain 32 images. Here you can see that train example dot shuffle, so we're gonna shuffle it, then we're gonna format it. So actually we're gonna use the map method to resize and scale all the images, then we're gonna apply the batch size which is 32, and similarly for validation and for testing. So we're gonna actually creating the batches of 32 images for all these three types of data set. The next step is to inspect the batch. So here you can see that we printed a batch information, and there you can see that each batch contains 32 images, and each image is of size 224 by 224, and here 3 is indicating the 3 colors which is RGB values. So that is the size or shape of our batch. The next step is defining the model, but now our model contains two portions. The first portion is already trained machine learning model, which is MobileNet v2 in our case, and the second portion is the layer which we will attach at the end, and that is retrained for our dataset. So the first portion we name it feature extractor layer. So here you can see that a variable name do fine tuning. So what this variable will do? So we have an option to retrain our mobile machine learning models. So if you want to do fine tuning or you want to retrain MobileNet v2 model, then you can enable this option, otherwise you can left it. And here you can see that for speed we start with a non-trainable feature extractor layer, but you can also enable fine tuning for greater accuracy. So if you enable do fine tuning, then it will take more time, but the accuracy will be greater than if you disable this option. And the next step is defining this non-trainable feature extractor. So here feature extractor using hub.keras layer, we define this module handle that we discussed earlier. So here we are defining the type of model we are using. So here you can see that mobile handle contain the information that we are using MobileNet v2 model. So we are using this module handle here. So there you can see that. So we are using this module handle there. And the next step is input shape. So we are specifying image size which contain 224 by 204, and now we attach 3 at the end which is for RGB values. So now the image shape is 224 by 224, then a third dimension is containing 3 which is for RGB values, and the output shape for this feature extractor contain FV size which is 1280 in our case. And here you specify trainable to do fine tuning. So if you are retraining, then do fine tuning will contain true, otherwise it will contain false. So for our case it contains false. Now the next step is to define the model. So using tf.keras.sequential, we specified our feature extractor here, and we specified the other part of our model which is tf.keras.layer.dense, and here the num class is which is actually 2, so the output for this layer will be 2, and the activation function is softmax. So here this feature extractor output shape is FV size, which is 1280, and the input shape for this layer will automatically be 1280 and the output shape will be 2. So using model.summary, you can see the shape of your model. So here you can see that the first layer is Keras layer, which is actually our feature extractor, and the output shape is 1280 for it. And the number of params are this. So these are all the params for MobileNet V2 model. And the ending layer is dense layer, which we attached, and that is the other part of our model, and its output shape is 2, as we have only 2 classes for cats and dogs, and the number of trainable params are 2562. So here you can see the total params are this number and trainable params are 2562, and all the other params are non-trainable. And now if you enable do find training, here you will select the number of layers which will be retrained. So for example, if you decide to retrain the MobileNet V2 model, so it contains actually a lot of layers. So here you can see that it contains layers equal to 53 deep neural networks layer, and it's up to you to choose the number of layers you want to retrain. So for example, if you want to retrain 20 layers, then you can choose 20, but if you want to retrain all the layers, you can choose 50 here. So maximum you can retrain 50 layers. But for now, if you enable do find training, just choose the number of layers to 10. And now if do find tuning is true, if you are retraining this MobileNet V2 model, here we are gonna run a loop, and for each layer we are gonna enable layer.trainable to true. So we are specifying for each layer we want to retrain, we are specifying layer.trainable to true. So while model training, it will gonna check for each layer that the attribute trainable is true for that layer, then it will gonna retrain that layer. Otherwise, if do fine tuning is false, which is for our case, then feature extractor.trainable is equal to false. So for all the layers of this feature extractor, training is disabled. So hopefully you will get the idea that if you enable this do fine tuning up here, then it will gonna explicitly enable this feature, which is layer.trainable to true for all the layers, and otherwise it will gonna disable the feature layer.trainable for all the layers which are contained inside feature extractor. Now the next step is training our model. So if do find training is true, we are going to use model.compile, and here we are going to use optimizer, which is standard gradient descent, and the learning rate and the momentum. So these are the hyperparameters, so you can change them and test your results. Similarly, the last function is sparse categorical as cross entropy, and the matrix we are using is accuracy. So if you disable do find tuning, so we are not training our MobileNet V2 model or retraining our MobileNet V2 model, we are going to use optimizer equal to Adam and loss function sparse categorical cross entropy, and the metric is also accuracy. So you can also change this optimizer and loss function and check the results. So it's entirely up to you. Now we need to choose epoch, so we're gonna choose epoch equal to 5. So we're gonna run this process for 5 times, and now we're gonna start the training. So using model.fit function, we specify train batches here. So the epochs will be equal to 5, and the validation data set will be validation batches. So now when you run the training, you will get the results. So here I already run it. So here you can see that for the first epoch I get accuracy equal to 0.998. So I'm getting accuracy, which is training accuracy, equal to 98%, and the validation accuracy is also 98.41%. Similarly, for the second epoch, I'm gonna get a 99% accuracy, and the validation accuracy is near to 99. Similarly, for all the epochs, you can see that the final results that our training accuracy is 99%, and the validation accuracy is almost 99%. So our model training is quite successful and quite accurate. So now the next step is to save the model or export the model. So we are going to use saved model format. So previously we used Keras model format, but now we are going to use saved model format. So firstly, I created a variable cat versus dog saved model, and here you can see that it contains the name with which it will be saved. Now tf.savedModel.save, and here you will specify the model you want to save and the cats versus dogs variable, so with the name with which you want to save this model. Now using tf.lite.TensorFlow Lite converter.from saved model function, which is the function to get an object of type TensorFlow Lite converter from saved model format, and here I specified this name with which this model is saved. Now using converter.convert, I'm gonna get a tflite file, and I'm gonna store this tflite file with the name converted model.tflite. And here you can see that we opened this file and we wrote the model inside this file. Now our model will be saved inside a file converted model.tflite, and here you're gonna see the file. So when you are gonna run it, you will see a converted model.tflite file there. Now the next step is to save the labels.txt file. So we have only two labels. The first one is for cat and the second one is for dog. So we're gonna open label.txt and we're gonna enter only two values, cats and dogs. So there you can see that I already run the whole notebook. So I have my converted model.tflite file there and the label.txt file, and similarly exported saved model, which is a saved model format. And now the next step is to test the model using Python interpreter. So you can simply run all these 4 blocks to test the model using Python notebook, and you don't need to understand this code. So now when you run all of this code, you will get a ending block, something similar to that. And there you can change the index to test the model for different images. For example, when I change the slider to 7, you will see that the image will be changed and we will get the result. So here the image contains cat, and here the predicted label is cat, and the confidence score is 100, and the actual label is also cat. So our model is predicting 100% right. Similarly, if I change it to 4, and now let's test the results. So here it also contains a cat, and model is accurate in that case as well. So when for 0, now let's check, and it's also containing a cat, but our model is predicting it right. So unfortunately we're not getting any dog image here, but as you can see that we get a dog image, and the accuracy score or the confidence score is 94, and the correct label is also dog. So our model is very accurate and is predicting cats and dogs very accurately. Now the next step is to use this converted model.tflite file and label.txt file inside Android application. So now let's build our Android application for cats and dogs classification. Welcome to this lecture. In this lecture, we're going to explore the code for cats and dogs classification Android application. So I build a simple Android application, and I'm going to explain the whole code of this application to you in this lecture. So if you want to create a new project and follow the steps, so you can do that, or you can download this code and understand it with me in this lecture. So if you are creating a new Android Studio project, just move to your build.gradle file, and here the first step is to add AAPT options inside the Android tag. So here you will see that the Android tag is starting from here and it's ending here. So you just need to copy these 4 lines inside this Android tag, and these lines are specifying that our program should not compress the tflite files or the files with extension tflite or Lite. And the next step is to add the dependency for TensorFlow Lite. So you need to add this line as well. So implementation org.tensorflow Lite version 0.0.0. So you can check for new version, but for now I'm using that version. And after that you need to click the sync now button, which will be appeared here. Now the next step is adding the model inside the assets folder. So I have a model inside my assets folder. So here you can see that I have converted model.tflite file and the label.txt, and these are the files that we created in the previous lecture. So if you want to create a new assets folder, as it's not previously there when you create an empty project, so just need to click on this app and right click on it, and here inside new, go inside this folder and click on this assets folder. And now you need to click on this finish to create the folder. As I have already created it, so I'm cancelling it, and after that you just need to copy both of these files and you just need to paste them inside here, and just click on this paste button and these files will be placed. Now the next step is developing the UI of our application. So I created a very simple GUI. So my activity main contains the application UI. So I have just one activity, and that is activity main. So I'm going to click on this activity main.xml, and here you can see that the layout of our application. So I just have 4 images here, and these images I placed them inside my drawable file. So I have taken all these images from Google. So just randomly you download 4 images, 2 of cat and 2 of dog. And here my layout consists of a linear layout of vertical orientation, and it contains 2 different linear layouts of horizontal orientation. So the first linear layout is this, and it contains both images. The first one is of cat and the second one is of dog. Similarly, the other linear layout also contains 2 images. So it's a no big deal to arrange the layout. So, and similarly you can make your own layout. And now we need to look at the code for this application. So inside Java, click on this first button, and here you need to click on this main activity, as it's the only activity we have. Now click on this main activity. So now let's look at the code inside main activity. So I just created a simple variable m input size, which contains the size of image. Then m path contains the path of tf-lite file, and m label path contains the path of label.txt file. Then there is another object which is of type classifier. So I wrote a simple class classifier. It's actually dealing the stuff related to loading the model and getting the results and sorting them. So we will look at it in a moment. For now, just understand that the classifier class is actually doing all the work. We are just taking an image and passing to the classifier class, and it's actually returning us the result. So now inside our own create, we simply firstly calling initialize classifier method, and this method is written there. And as you can see that we are initializing this classifier variable inside this init classifier method, and here we are passing the getAssets method. So this classifier will have access to our assets. Similarly, we are passing the model path, the label file path, and the input image size. So its constructor is taking all these 4 things. And then we are calling initialize views method, and here you will see that we initialize our images. So actually we have 4 images, and we are setting an on-click listener for all of these images. So our main activity is actually extending view.onClick listener. So we are simply, for each image, we are calling find view by ID, then we are passing the ID of that image. Then using .setOnClick listener, we are passing the listener. We are passing this, as this class is extending the onClick listener. And now let's look at the code for this onClick listener. So when we extend this activity with view.onClick listener, it automatically requires to implement public void onClick method. So now let's look at this method onClick. So here we are firstly getting the bitmap. So we have a view for which this method is called. So for example, for the first image view, this method is called. Then we are casting this view to a of image view. So now, as you can see that this block is showing that we are casting the view to a type image view. Then we are calling this getDrawable method here. So now we have a drawable. So now this code is indicating that we just have a drawable, and we are now casting this drawable to of type bitmap drawable. So we now have this portion of code. So we now get a variable of type bitmap drawable. Then we are calling this getBitmap method, and we are storing this bitmap, and then we are passing this bitmap to the classifier.recognizeImage method, and here we are passing this bitmap, and this method is returning a list of results. So it's actually returning a list of type classifier.recognition, which is an object type we defined inside classifier activity, and we will look at in a moment. And after that we are showing this result. So we are showing the first element of this result list, as you can see that. Now we need to look at the code inside the classifier activity, because it's actually the mystery that is doing all the work, that is loading the model, that is taking the image, and that is determining the result and returning them. So now let's look at the classifier activity. So now let's look at classifier.java class. It's the main class that doing all the work. It's actually taking the model parameter. So now let's look at the classifier.java class. It's the main class that doing all the work. It's taking the model path, label file path, input image size, and it's actually returning.
So now let's look at classifier.java class. It's the main class that is doing all the work. So it's taking the model and label file path, and then it will take an image and return you the result. So firstly we call this. So now let's look at classifier.java class. It's the main class that doing all the work. It's taking model and label file path, then it will gonna take the image and return us the result. This file is also shared with you with the name classifier.java, and you can use this class in any of your Android Studio project in which you are loading a TensorFlow model and passing the image to the model and getting the result. As this class is written very generically, so it's very useful, and you will see that we will use it inside our next sum of the projects. So now let's look at the classifier class. So firstly we are calling its constructor.
So its constructor is taking a variable of type asset manager, then the model path, then the label file path, and the input image size. And here you can see that firstly we initialize input size, so the input image size will be 224. And if you are using other Inception v3 model, you can specify your image size, which will be, I guess, 299. So I wrote this code so it will not be a big deal to change it if you are changing the image size or model. And now you created a variable of type interpreter.options, and now using interpreter.options you are setting the number of threads you want to allocate to the interpreter or TensorFlow Lite interpreter. So for now we are allocating 5 threads, and after that we are determining whether we want to use neural network API or not. So I'm passing true, so we are using neural network API, and after that we are creating an object of type TensorFlow interpreter. So here you can see that TensorFlow interpreter object, and we initialized it here. So interpreter is equal to new interpreter, and we are passing this method here, load model file, and this method is taking asset manager, the first variable, and the model path. Now let's look at this load model file. So here when I scroll down you will see a method load model file here. So it's actually taking an asset manager and the model file, and after that it's loading a model in mapped byte buffer as we previously discussed. So now we initialized our interpreter object. The next step is loading the labels file. So load label list will load the labels file inside this label list variable, and the type of this label list is of a list of simple strings. So now this list will contain cat and dog for this problem, as the file is only contain these two values. After that we call the recognize image method of this classify class and passed our image bitmap here. So here is that method, and we are taking an input image which is in bitmap format, and after that we are creating a scaled bitmap. So we are resizing that bitmap. So we are passing simply this bitmap and resizing it to 224 by 224, and after that we are getting byte buffer for that bitmap. So we are calling convert bitmap to byte buffer method, which is written here, and this method will actually take a bitmap and convert it into a byte buffer, which will be passed to our TensorFlow interpreter. So here we get our byte buffer, and then we are creating a array of type result. So this array will be passed to our model, and result will be stored inside this array. So it's actually a 2D array, and it will gonna store the label or the result. And after that we are gonna call interpreter.run method, and we are passing this byte buffer, and this byte buffer which is generated for this bitmap, and we are passing this byte buffer and this result array, and this result array will be populated with the result. And after that we are returning get sorted result float. We are actually calling this method, and this method is actually returning a list of type recognition object.
So now let's look at our recognition class. It's an inner class, and it contains 3 variables. First is a string of type id, the second is a title, which is either cat or dog, and the third one is a confidence score for the predicted label. So its constructor is taking these 3 parameters and initializing these values, and it actually contains a toString method which is returning the result in a string format. Here now let's look at this method name getSortedResult, as our recognize image is calling it at the end. So our recognize image is calling getSortedResult float and passing this result 2D array, and this method is actually returning a sorted list of recognition objects. So here you will see that it's returning a list of recognition objects. So it's simply creating a priority queue, and it's comparing the value passed to it on the basis of confidence score. So here you can see that we passed a comparator, and the type of class which it will gonna compare is of recognition type. The second method we are calling is recognize image, and we are passing our bitmap to this method. So this method is actually taking the bitmap, and after that it's scaling that bitmap to image size. So here you can see that we are creating a create scaled bitmap method, we are calling it, and we are passing our bitmap and specifying the input image size, which is 224 for our case. And if we are using Inception v3 model, the input image size will be 299 for it. So you can just simply change the input image size if you are using a different model. Now you need to convert this bitmap to a byte buffer. As our TensorFlow interpreter is not taking a bitmap, it's actually taking a byte buffer. So using convert bitmap to byte buffer, we are passing this scaled bitmap and we are getting a byte buffer as previously discussed. So this method convert bitmap to byte buffer is actually converting the bitmap to byte buffer format. And after that we are creating a 2D float array of name result, and it is actually storing the result. Then we are gonna call interpreter.run method, and we are passing this byte buffer, which is the byte buffer for this bitmap, and we are passing this result array. So our interpreter will gonna run the model on this byte buffer and store the result inside this result variable, and after that we are returning a method. So we are calling the method get sorted result float on this result object, and we are returning the value returned by this method. So now let's look at this get sorted result float method. So this method is written here, and this method is returning a list of type recognition. So what is recognition? Recognition is an inner class that I created here for keeping things simple. So recognition class contains 3 attributes: first a string ID, then a title, then the confidence score. So title will contain the name of label, which is either cat or dog, and the confidence will contain the confidence score for that predicted label. So that is the constructor and a toString method. So this will return the results in a string format, this toString method. So now let's look at this get sorted result float. Is actually creating a priority queue, and here you can see that we specified a comparator, and here the type of class which it will gonna compare is of recognition. So this comparator is comparing objects of type recognition, and here you can see that it's comparing the value based upon the confidence score. So it's actually gonna help us to sort the result based upon confidence score. After that we are running this for loop, and we are passing each value contained inside this label prop array to our priority queue, and it will gonna sort it automatically. And at the end, this priority queue is actually, we are converting this priority queue to a array list of type recognition using this for loop, and we are returning this array list of type recognition object. And now we call this method here inside our recognize image. So this method is actually returning a list of type recognition, and this list is actually returned by this method. And inside our main activity we are getting this list, and we are printing the first element of this list. So now let's run our application, so you will have a better idea that how the code is working. So now I have installed my application inside an emulator. So this emulator is running Android 10. So now let's test our application. So when I tab on any image, for example the first image, so when I tab on it, you will see that our model thinks it's a cat and the confidence score is 99.6%. So our model is working quite well. Similarly, when I tab on this dog image, you will see that our model thinks it's a dog with confidence score 99.9%. So our application is working correctly. So now you should have the idea that how you can train your machine learning model and use them inside your entire application. For example, the technique we used here, we are just simply passing the model name, model file name, the label file name, and the image to our classifier class, and he is returning us the result. As you can see that we are just passing the model path, the label path, image size here. Then when we want to get the result for image, we are just simply passing the bitmap and getting the result and showing them in a TOS. So this is just a beginning for you. So now it's up to you to train your machine learning models and develop Android applications for them with amazing features. For learning more about TensorFlow Lite use in Android with advanced example, kindly visit the course page at Udemy. Link is given in the description.